All right, let's dive into one of the weirdest, most fascinating ideas in all of science, quantum entanglement. Get this. It's a concept so strange it completely baffled even the greatest minds, but it also just might be the key to our entire technological future. So let's get into it. Just imagine for a second. What if you could link two tiny particles together, almost like they share a secret? Then you pull them apart. One stays here, and the other goes, well, anywhere. To the other side of the room or the other side of the galaxy. What if, by looking at one of them, you could know the secret of the other one instantly? And I'm talking instantly. This whole idea felt so wrong, so completely against the rules of the universe, that Albert Einstein himself couldn't get behind it. He famously called it spooky action at a distance. To him, it was just too weird to be true. He was convinced there had to be a mistake. But, as we're about to see, the universe is a whole lot spookier than even he gave it credit for. So, how do we even begin to wrap our heads around something this, well, spooky? Let's take a step back from quantum physics for a minute and try a simple analogy. This will help us get the basic idea, right before we see how reality is even stranger. Okay, picture a pair of gloves. That's it. You know there's a left one and you know there's a right one. They belong together, right? They're a matched set. Super simple. All right, now here's the fun part. Without looking, we're going to put each of those gloves into its own identical sealed box. We give one box to you, and the other one, we put it on a spaceship and send it to the far side of the universe. I mean, we're talking millions of light years away. That connection between them is still there. It's just stretched a lot. So, you're standing here with your box. You pop it open, and inside, it's the left glove. Now, in that exact split second, what do you know for sure about that other box all the way on the other side of the cosmos? Instantly, with 100% certainty, you know the other box has the right glove. No phone call, no text message had to travel between them. The information just appeared because they were always a pair. Now, this makes total sense, right? It feels logical. But here's the kicker. This is not how quantum entanglement works. Not even close. That glove analogy, it's a really great starting point, but this is the moment where we have to throw part of it out the window. Because with the gloves, the outcome was set from the beginning, and in the quantum world, things play by a completely different and much more mind-bending set of rules. Here's the crucial difference. The glove in your box was always a left glove. From the moment we packed it, it was a left glove. You just didn't know it yet. But a quantum particle is, well, it's undecided. It exists in this fuzzy, weird state of all its possible options at once. The act of you looking at it, of measuring it, doesn't just reveal its state, it literally forces it to pick one. And in that exact same instant, its partner, light years away, is forced to immediately pick the opposite. So you might be thinking, okay, this is some bizarre abstract physics stuff. Why does this matter to me? Well, it turns out this spookiness isn't just a weird quirk. It's the engine that's going to power a whole new technological revolution. We can actually harness this strange connection to build computers that will change everything. Let's see how. Think about the computer or phone you're using right now. Everything it does boils down to billions of tiny switches called bits. They can either be off or on, a 0 or a 1. That's it. But a quantum bit, or a qubit, is a total game changer. Because of that quantum weirdness, it can be a 0, a 1, or both at the exact same time. It's kind of like a coin spinning in the air before it lands heads or tails. So a single qubit is already pretty amazing. But what happens when you link them together with entanglement? Well, that's where the real magic happens. Entanglement is like the thread that ties them all together. Once they're linked, they stop being individual spinning coins and start acting like one single, incredibly powerful system that can explore a huge number of possibilities all at once. So what can we actually do with all this power? Well, we're talking about solving problems that are literally impossible for even the fastest supercomputers today. Things like designing life-saving new medicines in days instead of decades, discovering revolutionary materials we haven't even dreamed of yet, or building artificial intelligence and financial models that are powerful beyond belief. These are things that would take a normal computer billions of years to figure out. It's pretty amazing when you think about it. We've gone from a strange puzzle that bothered the heck out of Einstein to a tool that could completely redefine our world. But let's zoom out for a second. Beyond the technology, entanglement hints at something really profound about reality itself. I mean, really think about that. If the tiniest, most fundamental building blocks of our universe can be linked so deeply that distance becomes meaningless, It suggests that reality is far more interconnected than it looks. It challenges our whole idea of what it means for things to be separate. So the question I want to leave you with is this. If the universe is connected in such a fundamental way, what does that say about everything else in